Welcome back. This is lesson 4 of Machine Learning Zoomcamp session 10. And in this lesson, we will run together the TensorFlow serving model and the gateway service locally. And we will use Docker Compose for that. To remind you what we have done so far, we run this TensorFlow locally using Docker. We used the official TensorFlow serving Docker image for that. And then we mounted the model we had to a location inside the container. Then the other thing we did is we wrote some Flask code for the gateway service. So we already have all the code for downloading the image, resizing it, and communicating with TensorFlow serving using gRPC and protobuf. And we created a Flask service, and we even created a virtual environment for that using pipelines. Now what we want to do is we want to run both these things at the same time locally and then test how they communicate. And we want to use Docker for that. Before we were using Docker for running TensorFlow serving only. Now we also want to put the gateway service in Docker and then run both of them at the same time. So this is what we want to do in this lesson. Okay, let's start. The first thing we will do is prepare the Docker image for the TensorFlow serving service. The image we used is the official image from TensorFlow serving, but it doesn't contain the model. So what we need to do is when we run it, let me type it here. So we use Docker run, then itrm. Then the second line is we do the port mapping. So we map the port 8500 to 8500. Then we map the volume of current directory, then clothing model. Then we map it to /models/clothing model/1. This is the version. And then we need to specify the environment variable model name, which is clothing model. This and this have to be the same. And then we say TensorFlow/serving, and then the version is 270. This is what we use for running the model. So let me run it. Yeah, so this is what we did last time. So now what we want to do is instead of doing that, instead of mapping the volume, instead of specifying this model name and all that, we want to put everything in a Docker image. So next time we run, we just specify the Docker image here without doing all the mounting and setting the variable name. Because if we want to deploy it later, we want this image to be self-contained. So let's create a Dockerfile for that. So I'll create a file, I'll call it image model.dockerfile. So this will contain the Dockerfile we want to. Yeah, okay. Let me install the. I think it will be showing me some hints from TensorFlow serving, then the tag. I need to do a few things here. The first thing I want to do is copy the model. Instead of doing the mapping here, I just copy the model. So let me copy this thing. So I'm copying the model to this location. Right, and then I need to specify the environmental variable, which is model name. And the value is this one. And I think that's all I actually need to do. So let me build this image. I'll stop it now. Docker build -t. So the tag will be Zoomcamp 10 model, and the model in our case is exception. It's I don't know, v4001. And then the other thing I need to specify, because right now the Docker file that we created, the name of this file is not Dockerfile. The name is image model.dockerfile. So we need to tell Docker that this is the file that we want to use for building the image. So for that, we use -f to say what the file is. The file is image model.dockerfile, and then dot meaning that we want to do it in this directory. Because in this directory, we have folder with the model, we have the Dockerfile here. So we use the current directory. Let me run it. Okay, so we successfully built the model, and now let me copy that, and I'll create a new command for running it. So I don't need this part. I don't need this part because we already have that in the image. So we only need this. We still need to do the port mapping, and we just run this image. So let me run that. We can test it. So we have this gateway.py file. So I'll uncomment this part and comment this part. So we can just run it to see if this thing can connect to our TensorFlow serving model. So let me test it. Open a another terminal. Yeah, I'm in the right directory. So now let me execute this. Let me do this from pipenv run python gateway.py. It works. Now we have an image for TensorFlow serving model. So now it's in Docker. We built a Docker image for that. Now we need to do the same for our gateway service. I think I want to comment this and uncomment that because we will put this file inside the Docker image. So now let me create a new file. I'll call it image gateway Dockerfile. For that, I'll go to session 5 about deployment and copy that. So Zoomcamp, so deployment, then I go to the code folder and we have the Docker file here. So what I'll do is I'll simply copy the entire thing and paste it here. So from here, we need all that except we copy a gateway. Then there is another file we have, which is proto.py. So we copy both these files to the current directory. Let me check if I haven't forgotten anything. So we copy pip file and pip file lock. We copy proto.py and gateway.py. I think that's all we need. And I think instead of predict, we need to have gateway. Okay, we save it and now build the Docker image. To Docker build -t. Then for the tag, I'll use something like Zoomcamp, then gateway. The tag I'll use will be, let's go with just 001. Then again, we need to specify the file. It's image gateway, and we use the current directory for building it. It finished building. Okay, so we have this. Let's run it. I'll prepare another command for that. So we have this for reference. Let me, you know what? I want to record everything we did here. Yeah, so this is the command we used for building it. Let me copy it. This is the command for building the model image. This is the command for running this. So now let me copy the command. This is the command for building the gateway. Now let me also write the command for running it. Let me take the tag. So we need to map port 9696 on the host machine to the port 9696 in the container. Yeah, that's all we need to do actually. Let me run it. So now we have two things running. So we have the gateway running in this tab. We have TensorFlow serving thing running in this tab. So both of them are running. Now let's try to test it. For testing, I think I have this test.py file that sends a request to this localhost 9696/predict, and it uses this picture of pens for testing the model. Let me open the terminal. So in terminal, I just do Python test, and it complains about something. This is actually expected. So let's see what we have. So it says status code unavailable, failed to connect to all the addresses. Does it say anything else? Yeah, that's basically what it says. So the reason we see this is because the gateway was not able to reach our TensorFlow serving. The gateway thing here is trying to communicate to TensorFlow serving, but it cannot. And the reason for that, let's say we have our host machine. So this is Ubuntu that I use, this host. And then on this host, we have two Docker containers. So one container is our gateway. Then the other container is TensorFlow serving. In gateway, we have our Flask application. And in TensorFlow serving, we have this C++ service for running the model. I'll call it just TF serving. TensorFlow serving uses port 8500, which we map to the host machine. So let's say these are the ports of our host. This is a port 8500, so we map it. And then for Flask, we have a port 9696. We also map it here, 9696, and we map it here. Let me rearrange it a little bit, move it up. Then on the same host machine, we have our test.py script. Test.py sends a post request to localhost to port 9696 to this one, which in turn goes to the container and then goes to Flask app. And then the Flask app is trying to send a request to this TensorFlow serving. But inside the gateway, what we configure that we want to send the request to localhost 8500, and for the gateway service, localhost actually means this container. In this container, it tries to find a port 8500, but there is nothing running there on this port. That's why it fails to connect. So it somehow needs to find a way to go this way and to connect to this port, and then from this port it would talk to TensorFlow serving. And so it needs to go to a different container and then talk to the service that is running there. To link these two services, they need to live in the same network. So what we can do is we can put them together in one network. And within this network, these two can talk to each other. Gateway will have access to ports of TensorFlow serving and the other way around. So if we put them in one network, they will be able to communicate with each other. We can actually do this using plain Docker. I think there is a way to somehow link the containers, but there is a nicer way of doing this, of linking multiple related services together, which is called Docker Compose. So Docker Compose allows us to run multiple Docker containers and then link related ones to each other. So all of them will run in a single network and will be able to talk to each other if needed. For using it, we first need to install it. So let me stop this thing here. So we need to install it. If you're running on Windows or macOS and you have Docker Desktop, probably for running Docker, you already have it. So you already have Docker Compose. I don't think I have it. You can check if you have it or not by running this Docker Compose command. I do not have it. I do have Docker, but I don't have Docker Compose. We need to install it. For that, let's just go to a search engine and look for Docker Compose. We will get to the official page of Docker. There is page install Compose. Yeah, there is a version like here. I'm on Linux right now. And this is what I need to run. So I need to download the thing that lives here. I don't want to put it to this directory. What I want to do is I want to create a directory in my home folder. Just let me cd to my home folder. So I'm in my home folder. So what I want to do here is I want to create a folder called bin. You can call it any other name. This is just how I usually do this. So let's create this folder bin. I'll cd there and then download the thing from here. So instead of using curl for downloading, I just use wget, and then the file name will be Docker Compose. I have it now. Now we need to make it executable. For that, we use chmod plus X means make it executable. So now we have it, and we can actually run it from here. But of course, we don't want to always go to this directory and run it. What we want to do is make it available anywhere in the system. In other words, we want to add it to our path. This is our path. When we do Python, when we execute Python, it goes to our path and then tries to find Python in each of these directories. And then it goes to Ubuntu Miniconda bin, and this is where our Python is, because the Python is from Miniconda. If I do which Python, I see that this is the Python from this location. So I want to add this bin to the path variable. For some reasons, I already have it. I don't remember adding this here. Probably I did it at some point and I forgot, but let me show you how to do this. For that, in Linux, we need to open bash rc file. This is the bash script that is executed every time you run a terminal. And then at the end of this bash script, so there is a bunch of things. And then at the end of the bash script, we need to add expert path. And then we add the folder we just created. It's home. This is our home directory /bin. And then we include this folder to the path, but we need to have the rest of the path as well. What effectively we do this way is we prepend the bin directory to our path. And this is what Anaconda is doing here. They do it in exactly the same way. So they just prepend it to the path variable. And we also do it this way. So I just saved it. If you don't use nano, I pressed Ctrl-O to save it. And then I press Ctrl-X to exit it. So now you can either leave the terminal and enter it again, or execute source bash rc. For this, to reevaluate this, to re-execute the script. Now, when I do echo path, for some reasons I already have it here. I don't know why, to be honest, and where it lives, where it's getting added. But here I have it one more time. And if I do which Docker Compose now, I have Docker Compose that lives in my home directory /bin/Docker Compose. So this is this bin directory that we have here. Now let me go back to the directory where we were. And now we need to create a special file. It's called Docker Compose file that describes what are the containers we want to run. Let me create it. So the name is usually docker-compose.yaml. And because I have Docker plugin, it immediately recognizes that it's a Docker thing. Then let me go back to this website. I think if we go to Getting Started guide, and there should be some example. This is how it looks like. So here in this example that we just copied, it has already a Docker file in the current directory. It builds it and opens port 5000 and then links it to Redis. Redis is a database that they also run. The first thing we want to run here is our TensorFlow serving model, or maybe I'll just call it clothing model. And then instead of build, we use image. This is the name of the image. So where we have this, yeah, we have this file here with the names of our images. So this is the image name. This is what we need to do. Actually, don't need to open ports here. These two things, they will live in the same network, so they will be able to talk to each other. This gateway, if they live in the same network, it can directly access this port. So we don't need to map this port 85 to our host machine. And this is what the line of code that I deleted is doing. I'll put it here because we will need it later. But for this, for clothing model, that's actually all we needed. We just need to specify the name of the service, which is clothing model. And then the image that we use for this is this one. Then for the other thing, we'll call it gateway. For gateway, the image we use is this one, Zoomcamp 10 gateway 001. So we put it here. And then here we need to open the port. We need to map the port 9696 on the host machine to port inside the container 9696. That is actually not enough, because remember we talked about that Flask here, it has this localhost 8500. And when we do this localhost within the gateway image, within the gateway container, it doesn't mean that it should go to a different container and look for the service there. So here localhost means try to find an application running on this container on this port. We need to change that. So instead of localhost, we want to point it to this thing here. For that, we actually need to make it configurable. Let me open gateway. So in gateway, it's not configurable now. It's hard-coded. It's always localhost. We need to make it configurable. We need to change it from localhost to something else. And for that, I think we need to import OS. The way we want to do this is through environment variables, and we can access environment variables using OS. So in OS, we have this function called getEnv, which accesses environment variables. And the environment variable we will have is TensorFlow serving host. And if this environment variable is set, then it will use the value for this variable. If it's not set, we can also use a default value. So let's say if it's not set, we'll use localhost, but if it is set, then we use whatever is there. And this will be our host. And then the channel that we will create, we use this host, and then the stub that we later create will use this channel. So this way we tell this gateway where TensorFlow serving service lives. Okay, so let me save it. And actually I will need to rebuild now. So let me rebuild it. I'll update the version. I'll increment the version. So it will be version 002. Let me execute that. Okay, and it means that in our Docker Compose file, we will also need to change that. And we will now need to specify the environment. So this is how we specify the environment variables inside Docker Compose. In usual Docker, we specify it using this -e. So this is an environment variable, and TensorFlow serving uses this environment variable for doing its stuff. So in the same way, we want to set up the environment variable for our gateway service. And if we do it through Docker Compose, we use this environment key. Here we specify the name. The name is TensorFlow serving host. And the value in this case will be, so the port is 8500, and the address will be clothing model. So here inside Docker Compose, each container will be accessible within this network that Docker Compose creates by its name. So for this one, if we want to access this gateway, we will need to write gateway 9696, right? And then this way we will be able to access the port 9696 running on this container. And for this, we will need to write TensorFlow serving and then the port 8500. And then it knows, okay, TensorFlow serving, you're talking about this container, let's go here. So this line means that clothing model, go to this service and look for port 8500 there. I think that's all we need to specify. For clothing model, we don't need to do any configuration. We just need to specify the image. For the gateway, we need a bit of configuration. So we need to specify the environment variable so it knows where the model lives. And then we need to map the port because here from our test.py script, we still want to use localhost to do the testing. So we want to do the mapping because test.py lives outside of the network. So it lives on the host machine, but outside of the network that Docker Compose creates. So we still need to be able to access the gateway. So that's why we need to map the port from the gateway service to the port on our host machine. So let's run it. So for that, let me stop this thing, TensorFlow serving, and let me stop. Yeah, I already stopped the gateway. And now let me run Docker Compose. For that, I just do Docker Compose up. I need to make sure that I'm in this directory. So in this directory, we have Docker Compose YAML file. And if I just do Docker Compose up, then it looks for Docker Compose YAML file in the directory where I am in right now. And it runs all the images that are specified there. We see that it shows the output from both services. So it shows the output from clothing model, it shows the output from the gateway. Both of them are running right now. We don't need to have two terminal windows for running them. We can just have one. And let's test it. So go to terminal here, like last time, and do Python test.py. Something is wrong. I think what is wrong here is I don't need to have this quotes here. Let me run it one more time without quotes. So, yeah, here it looks strange. It looks like it tries to include the quotes in this. So let me try one more time. Hope it works. No. Yeah, it does. Yeah, so now we get the request. So what happens there is now these two services that we run with Docker Compose, now they can communicate with each other. And there is an easy way of doing this. We just need to refer it by the name. And then internally, Docker Compose knows how to resolve this name. It turns this into IP of this container. So it does the resolution itself. We don't need to worry about that. Yeah, one last thing I wanted to show you. So yeah, we can stop it. We just do Control-C to stop it. So we can also run this Docker Compose in detach mode. So when we do this, we run our service, but then we get back our terminal. So we don't need to open multiple terminals. And especially here, I am using SSH to connect to a remote machine with Linux. So for me, it's kind of annoying to keep multiple terminals. So I can detach this thing from the terminal and then get the terminal back and do things like Python test, for example, and then get back the prediction. Then I can see what is running there. If I do Docker PS, so I have two things running inside Docker, gateway one and then clothing model one. And then yeah, once I tested everything, I can do Docker Compose down, and then it stops all these things. This is how we use Docker Compose for running multiple connected services on the same machine. So this is quite useful for testing. And what we also did in this lesson, we built two Docker images, one for each service, and we also made gateway configurable. Now we can set any host we want here. And this is actually something we will need later. But for now, we can test things locally. And the next step for us is take that and deploy this to Kubernetes. Before we actually deploy this, I want to tell you a few words about Kubernetes, and this is what we will cover in the next lesson. So see you soon.